Welcome back, campers. All right, so today we're going to talk about how to find the standard deviation within the set of data. Um, we're going to do it two ways. I'm going to show you how to do it the long way, which it is worthwhile to know how to do. And I'm also going to show you the shortcut from the calculator if you haven't figured it out already. So, as we talked about earlier, the range is the maximum minus the minimum. And here's two data sets. You'll notice that the range is the same. You'll notice that the maximum is the same. And you'll notice that the minimum is also the same for each of these data sets. So then what's the difference between the two data sets? Well, if you look at them just briefly, you'll see that there's a huge difference. Right? So the range doesn't tell us everything. The max and the min don't tell us everything. So what we can do is we can take a look at how far away is each term from the mean. That's called what we call the deviation, right? And the average deviation is called also called the standard deviation. The standard deviation. Okay, so we're going to look at the original data set 4327658. So 4, 3, 2, 7, 6, 5, 8. So the first thing we're going to do is calculate the sorry about that. Calculate the mean value, x bar. Once we've got the mean, we can find the deviations from the mean by subtracting. We can also do what we call x minus x bar squared. And then what we're going to do is add all of those x minus x bar squareds together. So first of all, you know the ways of finding the mean values. We can use the calculator to find the mean, or we can add up the values and divide by how many there are, right? So let's use that method. So 4 plus 3 is 7, 9, 16, 22, 27, 35. So if I take 35 and divide by 1, 2, 3, 4, 5, 6, 7 values, that gives me a mean of 5. Okay, so that's the first step, is that we find the average. We can double check that by going 4 plus 3 plus 2 plus 7 plus 6 plus 5 plus 8. Divide by 7. We're good. All right. So then what we're going to do next is subtract the mean from each of those values. And what this tells us is how far away each value is from the mean. These are called the deviations. Some of these deviations are going to be negative, like this one. Some of them can be 0. And some will be positive. Oops, this is 7 minus 5. Sorry, 5 minus 5. All of them are subtracting the mean. This is 7 minus 5 is 2. 6 minus 5 is 1. 5 minus 5 is 0. 8 minus 5 is 3. So these are all the deviations. Now, if we were to count those up, in other words, if we were to add them together, I'd go negative 1. Oops. Negative 1. Sorry. Plus negative 2 plus negative 3 plus 2 plus 1 plus 3. If I add those up, I get nothing. So does that mean that they don't vary from the mean? Well, of course they do, because the mean is 5, and these are all 5. One of them is, but not the others. So what we need to do is we need to normalize these numbers. So the normal process for which you normalize numbers is that you take the square root of the number squared. But it's a little more complicated than that. So what we do is we take the squares of these numbers. So negative 1 squared Negative 2 squared is 4. Remember, this is negative 2 times negative 2. Negative 3 squared, and so on. 1 squared, 0 squared, and 3 squared. Then we add these numbers up. So what that gives us a normalized, so they actually combine. So 1 plus 4 plus 9 plus 4 plus 1 plus 0 plus 9 gives us 28. Summation notation of the x minus x bar squares is 28. All right, so the next step after getting that 28 is we have to use the formula. Okay, so the formula for what we call the variance, okay, the variance we call s squared. Let me try that again. S squared is the variance. We take the number that we just got and we divide it by 1 less than the number of values. You would think that you'd divide it by n, but it turns out we do n minus 1, and there's a long, complicated explanation for that. This should be a divided by sign. And then the standard deviation is just the square root of the number that we just got. So in other words, the square root of the s squared, as I mentioned earlier. So once again, we take that sum, divide by n minus 1, and then take the square root. So the sum that we just got was 28. So we're going to divide it by, if you recall, n was 7. So we're really dividing it by 6. Okay, 4 2/3 would be your value here. So if I take that and I divide by 6, I get, remember also if you want to turn it into a fraction, you can say math fraction, 14/3. Okay, so 14/3. So s squared is the square root of, s squared is 14, which is the sum of all the x minus x bar squareds, divided by n minus 1, which simplifies to 14. It's 28 over 6, right? Simplifies to 14/3. Therefore, s is the square root of that number. So the way I do that on the calculator is I go second square root answer. Then I get a decimal value. Now that decimal value, 2.16, so we'll round that to 2.2. That value has the same unit as all the other values that you had. So if those values represents, let's say, pets in homes, then the average deviation or the standard deviation of pets would be 2.2. Okay, so I realize this is a really long process, okay, but it's worthwhile to try this process a couple of times just to get a feel for where the number comes from. Okay. So a couple of things about the standard deviation. It measures the spread about the mean and should only be used when the mean is chosen as the measure of center. Also, s has to be positive because s is a distance. Distance is never negative. So it has to be positive or it's 0. So you can imagine a dot plot where s is 0 is when all the values are exactly the same. Okay, so there's no variation here, so s will be 0. S has the same units of measurement as the original data, like I mentioned. And also, let's say if data is the height in inches, then S will also be height in inches. S is in inches. So that's just an example for you. And then S is not resistant, so a few outliers can really screw it up. All right, so here is a spreadsheet of, this is your health example exercise for the day. So we've got patient number 1 through 10, and we've got blood pressure before. So this is probably either systolic or diastolic. Hopefully it's systolic. Those tend to be higher numbers. And then after, who knows, maybe after a weight loss program, maybe it's after they started taking medication, whatever. So the change is the after minus the before. So these are the x values. These are the values of the variable that you're looking at. So if we were to try to find the mean and the standard deviation, we would use the same technique as before. Now, the calculator method, which is much faster, of course, is that we go into the statistics. You may have remembered we did this in the box plot section. Click Edit. If you're clearing out a list, you just go up, hit Clear, and back down. Up, clear, down. So what we're going to do is we're not going to type in all of the before and afters. We're just going to type in the changes. Okay, just the changes. Negative 13, negative 29, and so on. You have to use the additive inverse key if you want a negative number. Do not use the subtraction key. It will give you an error. 2, negative 10, and so on. 4, 15, negative 13, and negative 30. Okay, notice that this tells you how many are in the list. So very simple now. Once I've got my list typed in and I'm happy with it. By the way, if you go up to the name of the list, it shows you all of them there. If I click enter, if I needed to fix one, I can fix it here if I wanted to. All right. So I click stat, calculate one variable statistics. Earlier we had done the so L1. Earlier we had done the min through max, which was the 5-number summary. Well, if you stayed back up where they gave it to you, SX is the standard deviation. So positive 17.6. So we're going to talk about what that means. So negative 12.4. So X bar was negative 12.4. And S was it 17.6? So the average change, right? The average change in blood pressure was 12.4 millimeters of mercury less than before. That's what the negative means. And the standard deviation is from the mean, which was negative 12.4. The variation in difference of blood pressure is high. It's 17.6. As you can see, some of them went way down, some of them got higher, right? So what this might tell us is that the data vary wildly. The amount of change varies wildly. So it possibly could mean that the whatever it is that they did to get the new blood pressure values maybe didn't work. Maybe for some people it really worked, but maybe for others it didn't do anything. You know what I mean? So that's sort of what that tells us. This concludes the recording.